Honestly, are we gonna sit here and say he carried this song?
Mute the mic, please.
Definitely slid along.
Good morning, everybody. Hello. Students, can you hear me? Can you see the screen? Just checking.
Yes, sir.
All right, good. Okay, so we're gonna do a revision session on coordinate geometry, basically to go over the content that we did this week in class. We're starting a new topic from tomorrow, and it's very important that we understand this topic fully to be comfortable in that next topic. We're gonna be doing inequalities and linear programming. So it's really the linear programming part of it that is very important, that we are comfortable with coordinate geometry. So what I'm going to do, I'm going to go through this class exercise that we had. I'm going to just go over it one more time on the slide on the screen here. And then I'm going to do some past paper questions. All right. And so we can see the structure of those questions in the exam, and you see that what we're doing in class. We have covered the requirements, right? You see that what we're doing in class, we have covered the requirements of the topic. Now let's mute the mic, please. If you're not saying anything, just try and keep your mic muted, please. All right. So if you have a question, open your mic and ask a question, and then close it again, please. All right. So this question gave us these 2 points, A and B. These are the coordinates. That's point A, and that's point B. So I'm just going to write them down on the screen here. So A is a point -1, 5, and B is a point 5, -7. 5, -7. And then we have to do a series of things with those points, these things. All right. First thing I wanted us to do in part A was to calculate the length of the line AB. Well, the length of the line comes from Pythagoras' theorem, right? And we have not yet done Pythagoras' theorem on that topic, but that's the nature of mathematics. Sometimes, it's a matter of what comes first, the chicken or the egg. So sometimes you have to use something before you learn it formally. But this is something that you should know from earlier, third form, second form, Pythagoras' theorem. So it is as if to say we have the 2 points, A and B. This is A, and this is B. I'm trying to find the length of it. And so you can get it in terms of the coordinates here and here. But this length here will be the difference in the two x values. So we'll call it xb minus xa. And this length here will be the difference in the two y values. That would be yb minus ya. And so to find this length using Pythagoras' theorem, this then will be a right angle triangle. And so the formula for the length of the line using Pythagoras' theorem then will become, let me write it here now. Let me shift this away. Let me shift this all away and write it here. So I'm just gonna say for part A that the length AB is gonna be equal to the square root of this side squared plus this side squared. This side is the difference in the x values. Let me write it out this time. xb minus xa can also be xa minus xb, doesn't matter, because you're squaring it, plus this side squared, which is yb minus ya. So what we say in the class, it is the difference in the x values squared plus the difference in the y values squared. Let's put values to it now. So it becomes the square root of. The difference in the x values is this x value minus this x value. Or we could put it the other way around. It doesn't matter. Our squaring. All we need is a difference. So we're going to use this x value minus this x value as a difference. So it's 5 minus, but this x value is a -1. I was squaring that. We have to be careful with those negatives. So this really becomes a plus. That minus is a plus. I'm going to put the plus on it so I don't forget that that minus is a plus. So this is really 6. 5 plus 1 is 6. And we're going back. Plus the difference in the y value squared. So then it's this y value minus this y value. Or you can go the other way and say this y value minus that y value. But I like when you stay consistent with the direction which you subtract. So we're going to use this y value minus this y value. So that then is -7 minus 5 squared, because this y value is -7 minus this y value is 5. All right, so that's what we're working out. So this reduces to the square root. This becomes 6. So it becomes 6 squared plus. Inside here is -12. -12 inside the bracket squared. When you square this -12, it's going to become a +44. Now you can put this in the calculator and work it out, but I just want to explain. If you were to work it down, this 6 squared will become 36. And this -12 squared becomes a +144. And then 144 and the 36 is 180. So it becomes the square root of 180. And I can leave my answer as that since it's not an exact value. If you like, you can put it in a calculator and it can give you a reduced form of what this is. The calculator can do it for you. I also can give you the answer as a decimal, because the answer is not going to be exact, because that's not a perfect square number. I can leave it like that and just put the word units, because in coordinate geometry, the unit of measurement is units. When you calculate the length of something, it must have a unit. Centimeters, meters, feet, inches, something. In coordinate geometry, the unit of measurement is the units. And so if you calculate an area in coordinate geometry, you're going to say units squared. If you calculate volume in coordinate geometry, you're going to say units cubed. All right, so that is the end of the first question. Why do you go with that? But okay?
Yes, sir.
Yes, sir.
All right, let's move on to point B, part B. So part B wants us to use the same 2 points. I'm going to just copy it down, because I might have to just have it in front of us sometimes. So part B, let's copy it down here. Same 2 points, put in part B. And part B wants us to find the midpoint of AB, right here. Part B wants the midpoint of AB. So I always say to the students, the midpoint, they can think of it as an average point. So the midpoint, I'm going to give it coordinates M. We treat it like an average point. And so I say it is the average of the X values and the average of the Y values. And how do you get the average? You add the X values and divide by 2. So you're adding the X values, which is -1 and 5. You're adding them, -1 and 5. And you're putting that over 2. And for the Y values, you're averaging the Y values as a 5 and -7. So it's 5 minus 7 over 2. All right. And that's going to give you the coordinates of your midpoint. Now, this is going to work out to be a 4, because it becomes 5 minus 1 is 4. 4 divided by 2 is 2. So its result is 2. And then this now is going to be 5 minus 7. 5 minus 7 is -2. -2 divided by 2 is -1. So this one is going to become -1. And so these are the coordinates of the midpoint between A and B. The halfway mark between A and B that is it. That is the coordinates. All right, so we have completed the first 2 parts, part A and part B. The next thing I want us to calculate is the gradient of AB. Gradient of AB. Now, we all know gradient is rise over run. Part C, we want the gradient. Gradient, which is really the measure of slope. Common M is a symbol for A for gradient. I'm going to use, so capital M is a symbol for midpoint, using for midpoint, but common M, that's a common M. Might not look like a common M, but it is a common M. So common M is a symbol for gradient, and because it's gradient of AB, I'm going to put a subscript AB right here. So I'm identifying that as a gradient of AB. Now gradient is rise over run. And rise is the difference in your Y values. So if you're looking at this is like a sketch that we had here, this would be the rise from here to here, right? This would be the rise, the difference in the Y values. And this would be the run, because you're saying to go from this point to this point, you'd have to rise, just that the rise would be negative, and then you run that way. All right, so the rise is the difference in the Y values divided by the difference in the X values. And what I say to the students as well, the direction you go when you're taking the difference in the Y values, so these are the 2 Y values, you're taking the difference of them. If I subtract it this way for the difference in the Y values, then I must subtract the difference in the X values the same direction, that way. If I choose to subtract the difference in the Y values this way, this value minus this one, then I have to subtract the difference in the X values this way, same direction, because gradient has a direction component to it, and so we have to stay consistent the direction that we subtract the values. All right, so the difference in the Y values I'm going to use this time, I'm going to use this point minus this point. I'm going to do it that way. So I'm going to write the formula then as YB, meaning the Y value at B minus the Y value at A. That's the difference in the Y values for the rise, divided by the difference in the X values, which has to be, XB minus XA. Because I started with YB, I have to start with XB on the denominator as well. All right, I will be careful with all these negative signs about the place. I have to be careful. All right, so this then becomes the YB is -7. -7 minus, I'm putting down this minus. This is the YA. The YA is 5. The Y value of A is 5. Divided by, this is now XB, which is a 5. Minus, this is now XA, negative 1. So it becomes 5 minus negative 1. 5 minus negative 1. So this minus is a plus. And so negative 7 and negative 5 is negative 12. This is a plus. I'll put a small plus there. Minus is a plus right here. So that is like 5 plus 1, which is a 6. So divided by 6. So negative 12 divided by 6 is just negative 2. So this is negative 2. So the gradient of the line AB is negative 2. Simple as that. And then now we have completed part C. Part D now is asking us to get the equation of the line AB. To find the equation of any line, we need to know 2 things about it. We need to know the gradient and one point that it passes through. Since it's the line AB we're talking about, we have the gradient right here. This is negative 2. But we have 2 points to choose from. We have point A and we have point B. We can use any one of them along with the gradient. So let's say I'm going to use point A. For no particular reason, I'm just choosing point A. If you use point B, you're going to end up with the same answer in the end. So let's say I'm going to use for the equation, I'm going to use the point A, which is negative 1, 5, which is something that I need. I need a known point on the line, and I also need the gradient of AB, which we know as negative 2. So the equation that we're going to be using is what I call the BFF for the equation of a line. It is the point gradient form, because that form uses a known point and the gradient to get the equation. And it's written like this: y minus the y value at A, because A is the point that we're using. So, all right, y minus the y value at A equals the gradient, and it's the gradient of the line that I'm finding, AB, into x minus the x value at A. So these 3 values will come from this information here. All right, so let's substitute them now. And the x and y here, they represent a general point. They represent all points on the line. So you're getting an equation connecting x and y that can be used to locate points on the line. Points on the line will therefore satisfy the equation that we're going to end up with. All right, so let's substitute the values now. So it's y minus ya is 5. The y value at A is 5. So put in 5 there for the ya, equals the gradient, and the gradient is negative 2. So I'm putting negative 2. I'm putting negative 2 into x minus xa. Xa is negative 1. So I'm putting a negative 1 right here now. So this minus again becomes a plus. I'm going to put the plus there. This minus is a plus. All right. Then now, this is just negative 2. So I'm going to expand this negative 2. I'm just going to expand this negative 2 across this bracket. And so I'm going to get y minus 5 equals the negative 2 times x is negative 2x. And the negative 2 times is positive 1. Remember, that's now a positive 1. It's going to give me back a negative 2. Negative 2 times positive 1 is negative 2. And then I'm trying to make y the subject. So I'm going to take this negative 5 and transpose it on this side. It becomes a positive 5. So I'm going to get y equals the minus 2x that is here, the minus 2 that is there, and then this negative 5 becomes a positive 5 here. So getting a positive 5. And then this positive 5 and this minus 2 give me a positive 3. 5 minus 2 is 3. So I end up with y equals minus 2x plus 3. That is the equation of the line AB. This one is the equation of the line AB. And it is in the form that presents us with the gradient and the y-axis intercept, because we have y as a subject. So this is a gradient, as we know, but this now, the 3 is our y-axis intercept. It crosses the y-axis at 3. Right? So this is the line AB. Equation of line AB. So I've completed now this part D. The next part is asking us to write down, just write it down because no calculation is needed. Write down the coordinates of the y-axis intercept keyword here is coordinates, meaning plural. So we have to give the X and the Y coordinate at the Y-axis intercept. The Y-axis intercept value is 3, and on the Y-axis, the X value is 0. So for part E, that Y-axis intercept becomes the point 0, C. 0 is the X value, the C is the Y value, and the C we get it from the equation right there. All right, so the coordinates of the Y-axis intercept is simply 0, 3. So that is the answer for part E, 0, 3. All right, so finish that part. Next part, part F, wants us to again write down, no calculation needed. Write down the gradient of lines that are parallel to AB. Remember, the gradient of AB is -2, you know. Lines that are parallel to AB will have the same gradient as AB. Parallel lines have the same gradient. So part F, the gradient of a parallel line, these 2 marks here that I've placed under the M, is my symbol for parallel. 2 lines running like that, parallel. So gradient of parallel lines will be equal to the gradient of AB. And the gradient of AB we know is -2. So the gradient of lines parallel to AB will be equal to -2, as easy as that. All lines parallel to AB will have the same gradient of AB, which is -2. Then now, part G is asking us to write down the gradient of lines now that are perpendicular to AB. Perpendicular lines to AB. And perpendicular lines have what we call negative reciprocal gradients. The gradient of perpendicular lines have a negative reciprocal relationship, meaning that the gradient of one line is equal to -1 divided by the gradient of the other line when they are perpendicular. So let's write it down here. So for part G, the gradient of perpendicular lines, and this is my symbol for perpendicular. So if you look at it, it looks like I'm forming a perpendicular right there. That's my symbol for perpendicular. So while this is my symbol for parallel, this is my symbol for perpendicular. I can just put a small cross like that for my symbol for perpendicular. So this is my perpendicular. This is my parallel. This is my perpendicular. So the gradient of any perpendicular line to AB is going to be equal to -1 divided by the gradient of AB. -1 divided by the gradient of AB. Remember, the gradient of AB is -2, you know. So I can take this -2 and drop it under here to do my calculation for the gradient of the perpendicular gradient. All right. So if you drop it under there, it is going to become -1 divided by -2. Then the negatives will cancel and give me a half. So the gradient of the perpendicular line will be equal to a half. Any line that is perpendicular to AB, the gradient will be equal to a half. Now, another way to do this calculation quickly is something that I call flip it and change the sign. Flip the one that you have and change the sign. The result will be a half, just the same. We're going to put that in red. So another way to do this calculation is to say flip what we have and change the sign. Let me write it out for you. Flip it and change the sign. That's a quick way to calculate perpendicular gradient. What do I mean by the sign? Meaning positive or negative. When 2 lines are perpendicular, one gradient will be positive, another one will be negative, and they will also be reciprocal of each other. All right. So since this gradient is negative, the perpendicular gradient has to be positive and is reciprocal. So if I start it, let's say I'm doing this flip it and change the sign, and I'm starting with this -2. I'm starting with this -2. Let me use a different color. I'm starting with this -2 as my gradient of AB. And I want to go to the perpendicular gradient. I want the perpendicular gradient. Then at this -2, I would view it as -2/1. When I flip it, it will become 1/-2. That's a flip, you know. So I've done the flip. And then after I flip it, I have to change the sign and make it a positive a half. That is how I get my perpendicular gradient. See here? My result is this perpendicular gradient. The perpendicular gradient from -2 to 1/2. So we could have gone from this -2 to 1/2 by simply flipping the -2 and change the sign, we'll get the half. And that's what this would do for us. But by calculation, we could substitute the -2 under here, as I did here, and then the negatives cancel to give me the same half that we have. But I go do that. But okay? But okay?
Yes, sir.
So for example, just one more example. If we had a gradient of 2/3 and we want the perpendicular gradient to 2/3, that perpendicular gradient to 2/3 would become -3/2, because you would flip the 2/3 and get 3/2, and then you would change it from a positive, because it's a positive here now. You would change it from a positive to a negative. Another example, if we had, for example, a gradient of -5/7, and we wanted the perpendicular gradient, gradient of lines perpendicular to the one that's at the gradient of -5/7, it will become 7/5, because we would flip it first and it become the 7/5, but first it would be -7/5, and we would change it from a negative to a positive. So this will be the perpendicular gradient. Another thing we must know about perpendicular lines is that the product of the gradients equal -1, meaning when we multiply the gradients, for example, if I multiply this times this, if I multiply them, it's going to work out to be -1. Similarly, if I multiply this and this, when I multiply perpendicular gradients, again, it becomes -1. Just as though if I multiply the -2.5, if I multiply them, it's going to be equal to -1. So the product of the gradients of perpendicular lines is -1. It's another good information to remember. All right? When you multiply perpendicular gradients, the result is -1. So the product of the gradients of perpendicular lines is -1. All right. So let's summarize what we have so far. We have that any line that is parallel to AB will have a gradient of -2, and any line that is perpendicular to AB will have a gradient of 1/2, 1/2. So that takes us now to part H, right here, part H. What is part H asking us for? It's asking us right here to find the equation of the line through P, or the equation of the line through P, which is parallel to AB, parallel to AB. So if the line that we want is parallel to AB, then it has a gradient that is equal to the gradient of AB. It has this parallel gradient, which is -2, and it is passing through this point P. So let's write down that the line that we're talking about. So the line that they're talking about in part H, talking about a line which is parallel to AB, and it passes through, I'm just going to write this for through, THRU. It passes through the point P34. To find the equation of a line, you need to know two things about it. You need to know the gradient and you need to know a point. They gave us a point, but they did not give us the gradient directly. They gave us information to find the gradient of the line that we want. They told us that it is parallel to AB. So since it is parallel to AB, then we're going to use the parallel gradient. So the line that we want will have the parallel gradient, which we worked out as being the same as the gradient of AB, which is -2. So we're using this gradient and this point to get the equation of that parallel line. We're using the parallel gradient and the point, and we're using again the BFF equation. So the equation of that line is going to be y minus the y value at P, because P is the point that we're using, equal to the parallel gradient into x minus the x value at the point P. This is the BFF formula. I call it the BFF formula for the equation of a line. It's very, very useful. The official name of it is the point gradient form, because you use a known point as we have here and the gradient as we have here. Those are the values we need to use this equation or this form for the equation of a line. All right, we don't need to use y equals mx plus c all the time. All right, so it's going to become y minus the y value at the point is 4. It's y minus 4 equal the parallel gradient is same -2 as the gradient of AB, -2 into x minus the x value at the point is 3. X value at the point is 3. So again, this is just a number multiplying this fraction, this bracket. We're going to expand this -2 over this bracket. We're going to get y minus 4 equals, this time this is minus 2x, and then minus 2 times minus 3 is positive 6. And then this -4, when it comes over, it becomes a positive 4. We want to leave y as a subject, and so y becomes -2x plus 6 plus 4. When this -4 comes over, it becomes a positive 4. And then the 6 and the 4 right here is 10. And so we have y equals minus 2x plus 10. So this is a second line. This is the parallel line through PQ, and that's the answer. Through the point P, parallel line through the point P. And this y-axis intercept is 10, and the gradient is the same 2 on that line. So if you draw this line on the graph, it is supposed to cross the y-axis at 10, and it's supposed to run parallel to AB because they have the same gradient. All right, that completes that part. Everybody good with that? Students, okay with that?
Yes, sir.
All right, we're moving now to part I, right here, which is asking us to find the equation of another line. This line now, they tell us that it passes through a point Q, but this one now is perpendicular to AB. So since it is perpendicular to AB, it has that perpendicular gradient that we worked up here, which was a half. The perpendicular gradient is a half, and it is passing through a point Q. Again, once you want to find the equation of a line, you need to know 2 things about it. You need a gradient and a point. In this example, again, they gave us the point. So we know the point. They did not give us the gradient directly, but they gave it to us indirectly by telling us that it is perpendicular to AB. And we know what that perpendicular gradient is. It is a half. And so the line that we want now, is perpendicular to AB. Perpendicular to the line AB. But it passes through the point Q, which is -3, -2. So we have the point already. What we need is the gradient. So we're going to be using the perpendicular gradient. The perpendicular gradient, which you know is a half this time. So we're using this gradient and this point to get the equation. We have the 2 things that we need. The equation is going to be, let's change the color again. The equation is now going to be, the equation of that perpendicular line is going to be y minus yq, because we are using the point Q, equal the perpendicular gradient, because it's the perpendicular line that we want, into x minus xq, because we are using again the point Q, and we're substituting the values now. So it's y minus the y value at Q is a -2. So we have to be careful now with these negatives. So it's y minus a -2. This y value is -2. So this becomes a plus, equal the perpendicular gradient is a half. This becomes a half into x minus the x value at the point is -3. Another case we have to care for the negative again, -3. This minus here again is a plus. Let's write another line. It becomes y plus 2 equals half into x plus 3. Now, if you like, you can expand the half over this bracket now. But an easy way of getting rid of the fractions to make the working a little bit more easy is to multiply the denominator of this fraction gradient over onto this side. Multiply it over here, and then multiply the 1, whatever number is here, multiply it across this bracket. All right, so that's a quick way to transpose it. I'm going to do it that way. Otherwise, if you want it, you could keep the fraction, multiply the half times x and get half x. Then multiply the half times 3 and get 3 over 2. You could have done it that way as well. But I'm going to multiply the 2 across here and get 2y plus 4, simple because that's a fraction gradient now, equal, I'm going to multiply the 1 inside this bracket, and the 1 times x plus 3 is just x plus 3. Then I'm going to transpose this 4 over here and subtract it, and I'm going to get 2y equals x plus 3 minus 4. But when this positive 4 comes over, it becomes a negative 4. And then the 3 minus 1 here is negative 1. So I'm getting that 2y is equal to x minus 1. That's my equation, you know. If I want to see the gradient and the y-axis intercept, then I have to divide through by this 2 now. So I have to divide each term by 2. This by 2, this by 2, and this by 2. To get rid of the 2, because I want to know have y alone as a subject. So if I divide through by the 2, this side is going to become y. This becomes x over 2, which is same as half x. I'm writing it that way because I want to see the m. And then this becomes negative 1 over 2. We could have also said that we are multiplying through by half, you know. That's another way we could get rid of this 2, you know. So again, if you multiply this by half, it becomes that. Multiply this by half, it becomes half x. If you multiply negative 1 by half, it becomes negative a half. So this is our y-axis intercept for that line, negative a half. And this is the other line now. This is the perpendicular line to AB. All right? So that's the perpendicular line to AB has a gradient of a half and crosses the y-axis at negative a half. All right? So that finishes that part of the question. Are they okay so far?
Yes, sir.
All right. The last part now is saying that we have to draw a graph showing all the points and the lines described up here. So we want to show all the points and all the lines that we have mentioned up here, and we're going to put them on this graph. This graph. All right, we're going to put them on that graph. All the lines and all the points. All right. All right, let's look at how we can do this now. So firstly, I'm going to scale up the graph. All right, so I'm going to go 1, 2, 3, 4. So I'm going to skip the ones. Don't really matter. So this is 1. I'm putting 2 here. This is 3. I'm putting 4 here. 5. I'm putting 6 here. 7. I'm putting 8 here. And then 9, and I'm putting 10 here. I'm doing the same thing on the next side, but it's negative. So it's negative 1, negative 2 here, negative 3, negative 4 here, negative 5, negative 6 here, negative 7, negative 8 here. I know the one that I got in the class, the graph was not this wide, but no problem, same concept. I'm going to put in the y values now. So I'm going to 1, 2 here, going up on the y-axis, right? Here's 2. 3, so this is 4. So this one is 4. 5, so this is 6. 7, and this is 8. 9, and this is 10. All the way up here is 10. I did this for the class because I wanted to show where the lines crossed the y-axis. Now we're coming down here now. So this is negative 2. I'm just going to write them in now. You must get a picture. This is negative 4. This is negative 6. So this line down here is actually negative 7. So we're going to need that for one of the points. All right, so putting on the points and the lines. Let's put on the points first. Let's put on the points first. Let me do them in blue. Do them in blue. All right, so first points were A and B. All right, A and B. Let's go all the way back to the top. So let me know A and B. So A was a point, negative 1, 5. So it means that we're coming back 1 and going up to 5 right here. All right, so negative 1, 5 is right there. So that is the point A. So we can mark this as our point A. And let's put A on it. That is our point A. Then we need a point B, which is 5, -7. So 5, -7 means we're going to go to the right 5, and then we're going to go down to -7 to locate this point. It's 5, -7. All right, so it's going to be right here. That's our point B. Then we calculated a midpoint M, which was 2, -1. So that's 2 across here, and then -1 going to be right here. -1. So that point is going to be here. 2, -1. That's a point M. Let's put an M beside it. Then we also had the location of the y-axis intercept in one of the questions, right? We were asked to locate the y-axis intercept, which was 0, 3. See it here? Let's call that point. We can maybe call that point C. Let's call that point C, 0, 3, which is right here. Y-axis intercept of the same line, 0, 3 is right there. So we can maybe call this point C. And then the first line was the line AB, and AB is passing through all these points. That's the line AB now. I don't have a ruler to draw it, but you have to bear with me. You should use your ruler and draw it. But the straight line through all these points is your line AB. I did a better job a while ago. Let's try it straight down like that. Nope, not good. Right, I'm just going to leave it like that, right? I can't get it straight with this device. You have to work with me. I can't get it straight, guys. That's what I'm getting. This app doesn't allow me to straight the line. But you get the picture. All right, that's better. So that's the line AB. That's the first line that we had. And if you want, you could actually extend it all the way up like that. All right? Could extend it all the way up like that. Because we did get the equation up. But that's the line AB. First line. All right? Now, the second line that we had was a line that was parallel to AB. Let's go for it. It was parallel to AB, passing through P. Right? Let me put on the red marker. So this line, the second line that we had, it was parallel to AB, and it passed through the point P. So I want to draw that line, and I can use the point and the gradient to draw the line. It's possible to use the point and the gradient to draw the line, because what gradient is a measure of how you rise and run from point to point on a line. Let me show it over here. So the gradient is -2. The line that we're going to do now. And the point is 3, 4. So I'm going to locate the point first. 3, 4. This is 3 coming this way. That is 3. And we're going up to 4. So this is the point we're talking about. Right there. So I'm going to mark it. So the point P will be right here. Point P. And we're trying to draw a line through it that has a gradient of -2. So we can use the gradient of -2 to rise and run to find other points on that line. But I'm going to write this -2 as a fraction that is -2/1, because my -2 will be my rise, and the 1 under here would be my run. Our gradient is rise over run. So this -2 rise means that I go down 2, and this +1 run means that I go to the right. So this means I'm coming down 2 and going to the right 1 to get to other points. So starting from here to get to other points on the line with a gradient of -2/1, I can rise -2, run 1. So see here now, I'm going to come down -2, run 1 to here. That's a point on the line. Then start again here. I'm going to rise -2 again, run 1. Let's look at it. I'm going to rise -2, run 1 and get this point. That's another point on the line right there. From this point, I can rise -2 again, run 1 to here. Get the picture? Instead of doing those small rise and run, the -2/1, I could scale it up, multiply it up. So for example, multiply it up by 4 and write it as -8/4, because it is still equal to -2. So in that case, I would rise -8, run 4. Rise -8, run 4. Starting here again, I would come down 8, 1, 2, 3, 4, 5, 6, 7, 8, and then run 4. 1, 2, 3, 4. That would put me here. And so I could do that big jump instead and get to that point. If you notice, all those points are still on the same line. You can see it. All right. So I can do a bigger jump, bigger rise and run. Instead of using the small 2 and then I get the 2 and the 1, I can use 8 and 4. Now, I can also go the other direction because watch this now. Watch this now. The negative 2 over 1 is actually the same as 2 over negative 1, you know. So instead of rising negative 2 run 1, I can instead rise 2 and run negative 1. So if I'm rising 2 and running negative 1, the rise 2 means that I'm going up 2, and then the negative 1 would mean that I'm going back 1. Right? So the rise 2 run negative 1. So let me show you now. Starting from the point P, I could go the other direction. Starting from the point P, I could rise 2, up 2, and go back 1 to here. And I can continue. Rise 2 and run negative 1, go back 1 to here. If I continue and I rise 2 and go back 1, you see that I come to my y-axis intercept, which was 10 on the second line. The C was 10. See here? Over here, the C value is 10. So it takes me to the y-axis intercept. So it proves that that method actually works. So you don't need 2 points all the time to draw a line. You can use the point, 1 point, and the gradient. Put down the 1 point and then use the gradient to rise and run to other points. So all those points are on this line. All those points are on this line. And you can see that it is actually parallel to this one. Those 2 lines are parallel. All right, so that will be that line. And I can continue down here like that. All right, so that will be my straight line. If I had a ruler, you would see it straight, but I don't have a ruler, but that is it. But I go to that. That is the second line. And again, instead of doing all this big rise and run, I could, for example, rise 8. Instead of doing 2 over negative 1, I could do 8 over negative 4. Right? Or 10 over negative 5. Still equal to negative 2. So I could make a big rise and a big run. Right? Instead of doing all those like small ones. So far, so good, guys.
Yes. Yes.
All right. So we need to do now. We need to do one more. The last line, which was a perpendicular line right here. So it passed through the point negative 3, negative 2. Let's put on the point first. Negative 3, negative 2. So we're coming back 3 and going down negative 2. Negative 2, negative 3. That's going to take us to that point right here. So that is where Q is located. Q. And then the gradient we're applying from this one now is a half. A half. So let me clear these now. We're going to do a gradient of a half next. And that from that point now. So if we're doing a gradient of a half, it means that we're rising 1 from that point and running 2 from this point. To find other points on the line that has a gradient of a half, we can, starting from this point that's on the line, we can rise 1, run 2. Instead of doing a small 1 and a small 2, we can multiply it up and put, for example, as 5 over 10, which is still a half, or we can put 4 over 8. We can put 4 over 8 to get other points, or we can put 2 over 4. Any multiplier that will be equal to a half, just the same. Mute the mic, please, can be used. All right. So let's go. Let's say we're using the 2 over 4. Let's say we're using the 2 over the 4. Starting from this point, we can rise 2, run 4. Mute your mic, please. Mute your mic. So instead of using rise 1, run 2, we're going to use rise 2, run 4 to get other points. All right. So we don't have too many points on the diagram. So starting from here, we're going to rise 2, run 4. 1, 2, 3, 4. That's going to take us to this point. Rise 2, run 4. And starting from here again, we're going to rise 2, run 4 again. Rise 2 to here, run 4. 1, 2, 3, 4. That's taking us to this point. Rise 2, run 4. Starting from here again, you can do another rise 2, run 4. So rise another 2, 1, 2, run 4 now. 1, 2, 3, 4 to here. Is that all those points are on the same line. Remember that the y-axis intercept for this line is also -2, negative a half, So when you draw the graph, it must be consistent. What you get by calculation and what your diagram shows must match. So when I draw this line, it must cross the y-axis at -a half for it to be correct, right? Because we join the line with a gradient of a half. That's why we rise. We use 2/4, which is same as a half. We could have rise 1, run 2 as well and get the points. But the bottom line is that when we draw the line, it must pass through the y-axis at -a half. So if I draw this line through these points now, it's going to go like this. Ouch. It's going to go like this. The perpendicular one. This one. That's it. And if I zoom up here, you can clearly see it's a different color. Right here is a half. This is 0. This is -1. This is -1/2. So you can see that it is consistent. It's crossing the y-axis where it's supposed to be at -1/2. So I have confidence in this line. Also, if you look at it, you can see that it is perpendicular right here, perpendicular to the line AB. You can see it on this graph that it is perpendicular, and also perpendicular to this other parallel one. You can see that as well. And basically, that was the question. That's a diagram. If I want, I can extend this back as well and get additional pieces down here. I can show you this rise 2, run 4. Instead, I can put it as -2 over -4. It's still equal to a half, still equal to a half, still equal to 2/4. So starting here, I can rise -2, run -4. When I rise -2, means that I'm going down. When I run -4, means that I'm going to the left. So starting at Q, I can go the other way to get additional points. So see it here. Starting here, I can rise -2, 1, 2, run -4, 1, 2, 3, 4 to here. And I can continue. But I won't get any more points on the graph. But if I were to show it, it will be rise -2 again. 1, 2, run -4, 1, 2, 3. Let's get a point out here. 4. Somewhere out here. Right? And so if I extend these lines, I could pass through those points as well, like that. That will be my line. So you can go the other direction with the gradient as well by just introducing a negative on the numerator and the denominator. That was the work from class this week. But okay?
Yes, sir.
All right, so I took about an hour to do that. All right? So we have another hour or so to practice some questions. All right? We're going to practice some past paper questions just to see how the questions are set in exam. All right, so let me start that now. All right, let me X this out. Start that now. So I'm going to start with 2022 question 4B. 2022 question 4B is right here. Let's look at it. So this is 2022 question 4B. This is the question. All right, so you can see the 2022 paper. Let's put a mark on it. All right, so 2022 exam. All right, and It's question 4B. All right, so what does this question say? It gives us a graph. So it shows this line on a graph right here. And it says the line L is shown on the graph below. And if we observe the line, we can see that the line crosses the y-axis at 1. So right off the bat, before you even calculate anything, you know that the C is equal to 1. What are they going to ask us for the equation? See what they say? Write the equation of a line from y equals mx plus c. We can see that the c is 1. It's obvious there. Question is, what is the m? You don't have to calculate it because you can see it on the graph. You can choose any 2 points and count the rise and run on the line. All right? So you can, for example, choose this point, use a red ink. Any 2 points on the line you can use that you know the coordinates for sure. So like this point and this point, I can count the rise. The rise is 1 unit, see, from 2 up to 3, 1 unit, and count the run. The run is 1, 2, 3 units, see, from 3 over to 6. The run is 3 units. So it's rise 1, run 3. This is the rise, and this is the run. I don't have to calculate anything because it's right there. So I can say that my C value is 1. So I can write it down. C equals 1. And the gradient M is rise over run between any 2 points. And I chose those 2 points. I can use any 2 points. It's 1 over 3. And so the equation, that's why I'm saying write it down, you know, because there's no calculation needed. And so the equation, this answer right here, is that y equals a third x plus 1, mx plus c. Done. But good at that? But okay with that?
Yes, sir.
All right. Next question. They said the equation of a different line is this. It says write down the coordinates of the point where this line crosses the x-axis. The x-axis. Now you know that on the x-axis, once there's a point on the x-axis, the y value is equal to 0. On the x-axis, y is equal to 0. So like you're taking 0 and you're plugging it into the equation right there to see what the x value is going to be. All right. So on the y-axis, on the x-axis, sorry, the y is equal to 0. And so to find the x value, plug the 0 into here, as I've said. And so you're going to get that 0 is equal to minus 2x plus 8. And if I transpose this to find the x, I can carry over the minus 2x and get 2x equals 8. Divide by the 2, I get x equals 4. Therefore, and it says the point is Q. Q is a point 4, 0. Q is a point 4, 0. But let me show you how we could find it another way from the graph itself. You could draw this graph on the line. Draw this line, sorry, on the graph. Because you know the y-axis intercept is 8. I know that the gradient is negative 2. So you could start from the point 8 and use the gradient as we did before to rise and run to find other points on the line to draw the line. Let me show you. And you're going to see that it passes the x-axis at 4, 0. Let's look at the graph and show you. So we're going to put it on the graph up here to see where it is. All right. So let me erase these. Don't need this now. So the line that we're talking about is y equals minus 2x plus 8. I'm going to put it at the top. Line that we're going to draw is y equals minus 2x plus 8. This minus 2 gradient same as minus 2 over 1, which means rise negative 2, run 1. We're going to start at the y-axis intercept of 8 that we know. So that line we know passes through here. So we can put that down as a point. We're using a gradient of minus 2 over 1. But instead of doing those small rise and run, we can just multiply up this by a, so for example, multiply it up by a 4 and put it instead as minus 8 over 4. The same gradient because this is still equal to negative 2. So we're going to rise negative 8 and run 4 starting from here. If we rise negative 8 from 8, it's going to take us all the way down to the x-axis. If we rise negative 8, like we're subtracting 8. And if we're here around 4, it's going to take us all the way over to the 4 right here. So you see that that point is on the graph. There's a point on it. Rise -8, that's -8 rise, and run 4, run 4. It takes us to this point. So it means that the line that we want passed those 2 points. Right? And you can see it. So it passed those 2 points. So we can draw the line to these 2 points. Let's draw it in a different color. Let's draw it in red. So the line that we want passed through that point on the y-axis, and the rise over run takes us to this point. If you want, you could use a small rise and run and get the same result. Let me show you. But I've used the same -2/1 and go from point to point. So let's look at it. We'll go like this. Rise -2, run 1. Look, rise -2, run 1 to here. Then rise -2, run 1 to here. Then rise -2, run 1 to here. Continue. Rise -2, run 1. You come to the same point on the x-axis. So we can take off all these markings for the rise and run. I said all those points are on the same line, guys. We need to understand this thing. And if you use your ruler and just join these points now, you get the line. Use your ruler and join these points, you get the line they're talking about. And they told us that the x-coordinate, x-axis intercept is q, which is 4, 0. So you could have gotten it another way, 4, 0. In any case, the answer is 4, 0. Either we'll get it from the graph or we'll get it by substituting the 0 for the y value here, because on the x-axis, as we said, y is equal to 0. Everybody good at that? Everybody okay?
Yes, sir.
And this question gives us an easy thing. Now it says, write down the coordinates of the point where the Q, the line Q, this is the line Q, you know, or we call it Q. Oh, sorry, it's not the point. The cross is the x-axis. Just need to write not Q. The line is Q. The line is Q. So the point is not Q. So let me go back up here. The line is Q, not the point. The line is line Q. What was the first line? The first line was line L. So this is now line Q. Let me extend it back. I call it Q. So this line is line Q. The line is Q. So this line is L and this line is Q. But this is the x-axis intercept, which is 0, which is 4, 0. And this is the y-axis intercept, which is 0, 8. And this is what this part is asking us for now. Write down the coordinates of the point where Q, the line Q, crosses the y-axis. That's the point 0, C. 0 and the C value, which is 0, 8. And it says coordinates. So if you write coordinates like that, with both values, the x and the y value. So that is the answer, 0, 8. All right, let me change this to blue. Let's change that to blue. All right. And then now it says on the graph, draw the line. We'll draw it already. So must draw the line Q. We'll draw it already. See there? That's the line, we drew it already. So this is the line Q that we draw in red. Very good. So you could have, maybe what they wanted us to do was to put down these 2 points and then draw the straight line through it. But we use a gradient and the point to do it. So it doesn't matter. It's the same line anyway. That is a line. Down here now it says on the grid on page 14, draw the line Q, which we have done. Then it says now complete the statement below. According to the graph, the solution of the system of equation consisting of L and Q. These are the 2 lines on the graph, you know. The line L and the line Q. The solution of the system of line. What they're asking about the point where they intersect. That's what the solution is. Is that in other words, if you were to solve these 2 lines simultaneously, what would you get? You're going to get the point where they intersect. So you just need to go on the graph and see where the 2 lines intersect. That's what they mean. System, the solution, or the system of equations consisting of these 2 lines. In other words, if you solve the 2 lines simultaneously, what will you get? You'll get the point where they intersect on the graph. And let's look at where that point is. The point there intersect. They intersect at this point right here. Let's mark it with a different color. Let's mark it in blue. The 2 lines intersect at this point. That point is 3, 2. 3 across, 2 up. So this point is 3, 2. 3, 2. the point where they intersect. So we can go and write 3, 2. 3, 2. So the answer for this is 3, 2. If you solve the two equations simultaneously that I gave you, this one and this one that we got for the first line, if you solve them simultaneously, the answer is going to be 3, 2. So if you want, you can test that for yourself. If you solve them simultaneously, you're going to get that 3, 2. All right. So I think that ends this question right here. Yes, it does. All right. Very good. But okay with that? Any questions?
Yes, sir. No, sir.
Let's look at another one. 2021. Let's look at 2021 and see coordinate geometry on that paper as well. So 2021, where are you? Looking for June 2021. Right here. All right, so this one is presented now. It's a coordinate geometry question again. So they give us those two lines and giving us some information about them. All right, it's a coordinate geometry question. Let's look at it. So the question said the diagram shows two lines right here. Line 1, so this is line 1. This is line 2. Remember, as you look at this line, you know it has a negative gradient because going from left to right, the line is going down. So you know the gradient is negative. And as you look at this line going from left to right, gradient is positive, it's sloping upward at a positive gradient. Also, about this line, you already know the y-axis intercept, you know the c value already. So the c value on this line, c value is -5. So we can make a note of that. All right. Now for this line, they actually gave us the equation. So we can get the y-axis intercept and the gradient from the equation by putting it in the form y equals mx plus c. That's what I said here. Line 1 has this equation, which I have shown on the graph here. All right, I've shown that. It says the line 2 passes through the point 0.5. So that's giving us a c value down here. That's where it crosses the y-axis. So now on line 2, c value is -5, and they tell us that they are perpendicular. So they have negative reciprocal gradient. Two lines are perpendicular. Write this over. So on this line, the c is equal to -5. They gave us the equation of this line, so we can get the gradient from this line. And because they are perpendicular, the two lines have negative reciprocal gradient. So since we don't know the gradient of line 2, we can say that the gradient of line 2 is going to be -1. It's going to be equal to -1 over the gradient of line 1. So we just need to find the gradient of line 1, and we can get it from the equation by putting the equation in the form y equals mx plus c. All right, and get the gradient of line 1, and then we will know the gradient of line 2 by flipping the line 1 gradient and changing the sign. But let's answer the questions as they ask us, right? Let's answer the questions as they've asked. So the first thing they want us to do is express line 1 equation in the form y equals mx plus c. It's a line 1 equation here, because they want us to be able to pull off the gradient from it and the y-axis intercept. So this is the line 1 equation. I want to make y the subject. So let's look at it. We have x plus 2y equals 10. First thing I'm going to do is transpose the x. When I transpose the x, it becomes 2y equals -x plus 10. Then I need to divide through by 2 or multiply through by 1/2. To get rid of this 2, because I need to get it in the form y alone as a subject, I'm going to multiply by 1/2 to get rid of this 2. Or you could divide through by 2, same difference. So this becomes y, when you multiply by 1/2, equals, you multiply this by 1/2, it becomes -1/2x. And when you multiply this by 1/2, it becomes a 5. So it means that this is the gradient of line 2. All right, and that's what they asked us here. State the gradient of not line 1. Sorry, this is the gradient of line 1. Line 1 we're on. All right, so this now they're asking us that here now. So they're helping us to solve the question now step by step. You know, they want us to state the gradient of line 1, which is this gradient. So I'm going to call it M1, which is equal to -1/2 the M value here is going to have line 1. Let's continue. Then it says in the next part, and determine the equation of line 2. So to find the equation of line 2, we need to know 2 things about it. Well, we actually know one thing about it already. We know that the C value is -5. And we also know that the gradient of line 2 is -1 over the gradient of line 1. Why? Because the told us that the 2 lines are perpendicular. So to get that gradient, remember the gradient of line 1 is -0.5. You know, we just worked it out a while ago. See it here? Right? So we can do this 2 ways. We can put the -0.5 under here and work it out. Or we can know that this calculation means flip this one and change the sign. Flip it and change the sign. If you flip it and change the sign, it's going to become 2. But I give it that?
Yes, sir.
Good. And so since we know the gradient and the y-axis intercept, we can write the equation. The equation, since we know the M and the C, the equation of line 2, the line 2 equation. Since we know the M and the C, we are simply using the y equals mx plus c. And we're using this gradient of line 2, the line 2 gradient and the c. So putting the values is simply y equals 2x and the plus c is -5. So we're just going to put -5 and that is it. Equation of line 2. Easy question. Anything else I want us to do? Let's see. Let's see if there's anything else. Nope, that's it. Want to go to that? But okay? This question?
Yes, sir.
Just did? All right, beautiful. All right, more maths equals better maths. So let's continue. Let's do another one. Let's look at 2019. There's another one on May 2019 that we can look at. Another coordinate geometry. 2019. Let's see that one somewhere here. Right here. All right. All right. So that's another one right here. May 2019. So this is how they presented this one. All right. Question says the equation of a straight line is this, and I present it like that. It says the line crosses the y-axis at Q, but determine the coordinates of Q. Remember, if it crosses the y-axis of Q, the coordinates of Q is going to be 0, C. So all we can do to this equation to get the C is to actually put it in the form, convert it into the form y equals mx plus c. In other words, transpose it and make this y alone the subject. Then we will see what the gradient is, and we'll also see the c value that we need here. All right, so that's how I'm going to do it. I'm going to put it in the form y equals mx plus c. All right, so let's do that over here. Let's do it over here. So what I'm going to do, I'm going to transpose this over here first. And when I transpose it, I'm going to get y over 7 equals negative x over 3. And this plus 1 is already over there, plus 1. But I go to that. But I go to
Yes,
that. Then to get rid of this 7 under here, I'm going to multiply through by 7. I'm going to multiply everything by 7. Let me write. I'm going to multiply through by the 7. That will eliminate the 7 that is under here. When I multiply 2 by 7, this becomes just a y, because the 7 is cancelled, equals, this becomes negative 7 over 3 times x. I'm writing it like that because I want to see the m. And this becomes 7. So I get a plus 7. Tell me if you can see that. But I can see that?
yes, sir.
This part might be the part that a lot of people might not see. Right? But that is what it is. If I multiply this by a 7, like I'm multiplying a 7 right here. When I multiply by a 7, like I put in a 7 right there. Multiply it by a 7. So it becomes negative 7 over 3 times the x. But I just deliberately write it this way. You can see that this is my m. I wanted to see that that is my m. All right, so that's my m. So based on that note, this is my c and this is my m. Let me write them down. So the m on the line is negative 7 over 3, and the c on the line is 7. All right, so that is just extra for me to write this answer now. So the answer for this, let's put a different color. This is just like my private working out, right? And you can leave it on the paper like that, guys. You can actually leave this on the paper like that. You can leave it. That is just your working out to help you answer the questions. Because now you know your M and you know your C. So the coordinates of the point Q is 0, C. So Q is a point 0, 7. 0, 7. Another way you could do it, is to say that on the y-axis, x equals 0. And if you plug in the x equals 0 here, then you'll be left with this. Y over 7 equals 1. And then if you multiply up the 7, you will get y equals 1. So the x value, y equals 7, sorry, y equals 7. Y equals 7 if you multiply up the 7 here. So the x value is 0 and the y value is 7. So you get the point still 0, 7. That's another way to do it. Get the same 0, 7. But I think maybe, the better way is to do what we did, because we might need the gradient. We might need the gradient. All right, let's see. We might need the gradient. Let's see. The next part wants us to see. The axis wanted the gradient in the next part. Didn't realize the gradient is this. So we just need to write it down. The gradient is -7/3. So we'll get that by putting the equation in the standard form, y equals mx plus c. That's right here. So we can see the gradient and see the y coordinate at the y-axis intercept, the 7. So this is the answer for this part. Let's see what else I want us to do. Whole question is done. See, that is all. So this is a question about putting the equation in the standard form so we can see the gradient and see the y-axis intercept. But okay with that?
Yes, sir.
All right, then. Let's look now at another one, which was on 2017. Coordinate geometry is relatively frequent on the exam, so you can almost certain to get it. There are a couple of years that they might skip over it, but for the most part, it comes on every exam paper, almost. Here's another one. This is on 2017, May 2017. Let's look at it. This one gives us two lines, a line 1 and a line 2. This is line 1, L1, and this is L2. Let's see what they say. Question says, the graph below shows two straight lines, L1 and L2. It says L1 intersect the x-axis at 0, 1. You can see that right here. So it means that on L1, let's write it out. On L1, we already know that the C value is 1, 0, 1, right? And it says line 2 intersects the x and the y-axis at 12, 0 and 0, 6. So 12, 0, that's right here, and 0, 6. So on L2, let's write it down. On L2, the C value is 6. C value is 6. All right. Now, because they gave us the graph, the lines, we can actually get the gradient by doing rise over run. You must know that this one has a negative gradient because going from left to right, it's going down. And this one has a positive gradient because going up from left to right, it's going up from left to right. All right. So let's continue now. They want us to determine the gradient of each of the lines, gradient of line 1 and the gradient of line 2. Let's call them M1 and M2. And I'm not going to calculate it. I'm just going to use 2 points and the rise over run. So on M1, let's do M1 first, gradient of line 1, call it M1. I'm going to come on the graph and use any random 2 points. I've decided to use this point. Let's do it in red. I've decided to use these 2 points. Any 2 points you can use. This point and this point. Going from left to right. I'm going to count the rise. Right? The rise is 2 units. This is 7. And this is 9. So the rise is 2 units. So rise 2. This is a run. Let's see what the run is. How many units? From 3 to 4 is a 1 unit run. 1 unit run. So this is the rise, which is a positive rise, and this is a run. a positive run. So it's 2 over 1, which is 2. So the gradient of line 1 is rise over run on the line, which is 2 over 1, which is 2. That's the gradient of line 1, 2. Then the gradient of line 2 now. We're going to come on line 2 and use any 2 points. Again, I'm just going to choose any 2 points on it. So for example, here and here. And I'm going from left to right. Starting from here, I'm going to have to come down. It's a negative rise. So that's a negative 1 rise. Negative 1 rise. And then I have to run 2 units. That's a 2 units run. So this is my rise this time. Rise, and this time this is my run between those 2 points. I have the graph. I don't have to calculate. I can just count out the rise and count out the run between 2 known points. From 6 to 8, you're running 2. From 3 down to 2, you're running negative 1. So for this line now, my rise over run for line 2 become negative 1 over 2. That is the gradient, negative 1 over 2. And I can see that the perpendicular now. Right now, if I multiply these 2 gradients, it becomes negative 1. So I can see that the 2 lines are perpendicular. By just multiplying this and this, become negative 1. So right away, the 2 lines are perpendicular. Let's see what else they want us to do. They want us to write down the equation of line 1. So remember, the gradient of line 1, remember, was 2. See it here? 2. And the y-axis intercept of line 1 is 1. C is 1. See it here? C is 1. Let's write them down. That's all they need. That's like a calculation. So the gradient is 2 and the C is 1. The equation is y equals mx plus c. Right here. So equation is y equals mx plus c when you know the gradient. And it's line 1 we're talking about. So it's y equals 2x plus 1. Easy like that. You have to do a big calculation because you can see the y-axis intercept and you can count out the gradient. That's it. What else they want us to do? They want us to say, what is the relationship between L1 and L2? Give a reason for your answer. The relationship between them is that they are perpendicular. Right? They are perpendicular. L1 is perpendicular to L2. Why? Because the gradient of line 1 times the gradient of line 2, which is equal to 2 times minus a half, is equal to negative 1. When the product of the gradient equal negative 1, the lines are perpendicular. That's it. See? That's the reason, you know, because the product of the gradient is negative 1. This question is testing your knowledge of this. That when lines are perpendicular, the product of the gradient is negative 1. This question was a lot about gradient. You have to remember that, guys. If the lines were parallel, the gradients would be equal. When the lines are perpendicular, the product of the gradient is negative 1. Or they are negative reciprocal gradients of each other. In other words, if you flip the 2 and change the sign, you get in minus a half. If you flip the minus a half and change the sign, you get in the 2. But to show that 2 lines are perpendicular, you can also multiply the 2 gradients and it must be equal to negative 1. When you multiply the perpendicular gradients, it should be equal to negative 1, which is what we did down here as our way of showing the relationship between them. They are perpendicular. But go with that.
Sir, I have a question.
Yes.
Sir, going back to the graph, you said that we use random points on the graph.
You can use any 2 points that's on the line to get the gradient. Any 2 points to count out the gradient. You just need to count the rise and the run between any 2 points. You're gonna get the same answer. If you even to use 2 points that are wider apart, like for example, if I use this point and this point all the way down there. To go from this point to this point, going from left to right, I have to come down here first, the rise, and then run across here. So this rise will be 1, 2, 3 units down. See, from 4 down to 1. It's 3 units down. It's a negative 3. And then this run is from 4 over to 10. That's a 6. A run of 6 units. See? The count it of 1, 2, 3, 4, 5, 6. A run of 6. So the gradient of line 2, as the line 2 we're on now. If you want to put it as a riser, I want to be minus 3 over 6. But minus 3 over 6 reduces to minus 1 over 2 anyway. So I don't usually go to any 2 points that are that wide. I come to 2 points that are closer once I can see the coordinates. I know the coordinates for sure. Like for example, instead I come to these 2 points here and here. Any 2 points. I could have used this point and this point. I could have used this point and this point. I could have used this point and this point. 2 points that I know. The rise is still -1 and the run is still 2. That answer the question?
Yes, sir.
All right, very good. Anybody else? Anybody else have a question? All right, good. All right, there's another question on 2016. Let's look at it. 2016, May 2016. We're doing the May ones first. All right, let's look at 2016 May. On June 2016. May, June. 2016 is right here. All right, here's another question. This time is question 6. Let's look at this one now. So this one gives us this line, x plus y equals 3. When we do linear programming, we're gonna see these lines a lot. X plus y equals some number. So when the line is x plus y equals some number, it crosses the y-axis and the x-axis at that same number. Like for example, x plus y equals 3. You see, it crosses the y-axis at 3 and also crosses the x-axis at 3. I call it the x plus y lines, a very popular line when we're doing linear programming. So for example, if it was x plus y equals 10, it would, so x plus y equals 5, it would use something on the graph. If it was x plus y equals 5, we want x plus y equals 5, we'll cross the y-axis at 5 up here and cross the x-axis at 5 as well. The x plus y line, I call it. And that line will run like this. So x plus y equals any number, cross the x-axis and crosses the y-axis at that same number. The more things you know, the better. Mathematics is easier the more things you know, and you don't have to be working out. And since this is one of the popular lines, x plus y equals a number, it's good to just know it, and we can see it here. Cross the y-axis at 3, cross the x-axis at 3. All right, because it's x plus y equals 3, and the gradient is -1. X plus y lines, gradient is -1. Because if I transpose the x, it's going to become y equals minus x plus 3. When it's just a minus x, like there's a 1 in front here, so the gradient is -1. X plus y lines have a gradient of -1. All right, let's continue to the question. So this is x plus y equals 3. What they want us to say? They say determine the equation of a line which is parallel to this line. So if it's parallel to this line, it has the same gradient and pass through the origin. All right, easy enough. Once it passes through the origin, the c value is 0. Good, c value is 0. And I just said the gradient of this line is -1, because if I take this line and put it in the form y equals minus x plus 3, then the gradient of this line is -1. Now, because the line that they want over here now is parallel to it, it has the same gradient. And any line to the origin is going to be y equals mx, because the c value is 0. Any line to the origin, the equation is y equals mx. And because you want a line that is parallel to this one, it will have the same gradient. And so the line that you want is simply y equals minus 1x. But I don't have to put this 1. So it's just y equals minus x. Y equals minus x. Minus x is that line. That is the answer. Y equals minus 1x or minus x. Somebody go to that? But okay,
Sir, can you go over that again, please?
over it again. All right, let's go over it again. All right, let's go over it again. So the first thing is that you want a line that is passing through the origin. So once it is passing through the origin, the C value is 0. And if the C value is 0, the equation then is just simply y equals mx. So we will only need to find the gradient. Understand that so far?
Yes, sir.
Good. Now, they tell us the gradient by telling us that the line that we want over here that is passing through the origin is parallel to this line that they gave us. So if it is parallel to the line that they gave us, it means that it has the same gradient as this line. So what is the gradient of this line? We can get the gradient by putting this line in the form y equals mx plus c by transposing the x. It's going to become y equals minus x plus 3. When this is just a minus x, it's just like a minus 1x. So the gradient that we're talking about is -1. So far, so good?
Yes, sir.
Good. And so the line over here has the same gradient of -1 and a C value of 0. So it means that the equation, if I put the -1 here, the equation therefore is simply y equals minus 1x. We don't write mathematics like that. We don't say minus 1x. If you leave this, they'll give it a mark still, you know. But, you know, to make it look more proper, we're going to say y equals minus x, because minus 1x same as minus x. You understand that now? So
Yes,
this is a line. All right, good. Everybody else okay?
Yes, sir.
All right.
Yes,
This
sir.
one says no.
Yeah.
Good. This one says no. They want the perpendicular line now, you know. The line that is perpendicular to this, you know. I want it pass to the midpoint of AB, you know. The midpoint of AB. You want the line passing to the midpoint of AB. And it must be perpendicular. So to find the equation of that line now, you need a gradient and a point. The point they're talking about is the midpoint of AB. Let's look at the diagram. It's kind of easy on this one. Because this point up here is 0, 3. This point up here, A, is actually 0, 3. And this point down here is actually 3, 0. Remember, midpoint is the average point, you know. The midpoint is going to be right halfway inside here, so somewhere. So it's going to be the average of these two x values. What's the average of 0 and 3? 1.5. Average of the x value is going to be 1.5. So it's 1.5, or you can say 3 over 2. It's like you add the 0 and the 3, you get 3, and it's 3 over 2. And you're going to average this 3 and this 0 next to get the y value at midpoint. Average them. 3 plus 0 is 3. And you put that over 2. So you get in 3 over 2 again. So the midpoint between A and B is simply 3 over 2, 3 over 2, 1.5, 1.5. And then you want the line that is perpendicular to it. So the line that you want, if I were to draw it, it runs this way. Let me shift this over. Perpendicular to it. Go like so. That's the line that you want, you know. Perpendicular to it. It passes through the origin as well. So I know the answer is y equals x. But you might have to work it out. That line is line y equals x. Right? So you want the line that is now perpendicular to this one. So the question is, what is the gradient of this line? This line that you want. Let's call it line 2. Right? Let's just call it line 2 so we can make a reference to it. Line 2. So it's line 2 we're trying to get. So we need a gradient at that point. The point is clearly this. So what is the gradient? So the gradient, the perpendicular line gradient, let's call it line 2, is equal to -1 over the gradient of AB. Gradient of AB up here says this, you know. The first line, you know, gradient of this line. All right, let's call it line 1 then. Gradient of line 1. Line 1, the first line, line 1. So like we're taking the minus 1 and putting it under here. So that becomes equal to 1. And if you flip the minus 1 and change the sign, it just becomes 1. So the gradient of the line that you want is 1. And it passes through the midpoint. I would say the midpoint is the point 3/2. 3/2. It's going to be y equals x is the answer. Y equals x. But if you work it out using the formula y minus yp, because this is the point P now. Let's call that point P, the midpoint. Let's call it P. Let's call this midpoint P. So it's y minus yp equals the gradient of the perpendicular line into x minus xp. This question I don't really need a calculation, but just to show you. So it will become y minus the yp is 3/2 equals the gradient is just 1 into x minus xp, and xp again is 3/2. So you realize what happened. If you expand it out, and it's not to expand really, you realize that this minus 3/2 cancels this minus 3/2, and you just end up getting a line which is y equals x. That is the answer, no, y equals x. Now, if you have advanced knowledge and so you could actually look at the diagram and see that it's this line. You can look at it and know that it is this line from the get-go. If you understand enough about the coordinate geometry, this line is just the line y equals x, because it has a gradient of 1 and it passes through a point where the x and the y value is the same. So the equation of lines with a gradient of 1, which passes through points where the x value and the y value is the same, is a line y equals x. Y equals x. So I could know it's y equals x from the get-go. So it also passes through the origin, 0, 0. But that is a line y equals x. What do I go with that? Sometimes some of these simpler questions are the ones that pose problems, to people, the most simple questions. It's a very simple question where you can literally look at the question and write down the answer. Right? The answer is pretty obvious. But sometimes the simple ones are the ones that give problems. That's why it's very important for you to know stuff. The more things you know, the easier things are. All right, but I go to that. You have anything else to do? No, that is it. Right?
Yes, sir.
All right. So we're gonna do a couple of general questions now. What time is it? How long we're going? All right, so about 20 minutes left. Got to some general questions now. So we'll look at January 2020. All right, let's look at January 2020. Some here. Let's look for it. January 2020. This is it. All right. So this one gives us 2 lines again on this graph, line 1 and line 2. So you see, I like to give question where they actually give you a diagram. Line 1 and line 2. And I like those because you can count out the gradient, you can see the y-axis intercept and so on. Right? I like when they show you the line. To me, it's easier when they show you the line. You can confirm what you get, because what you get by calculation must match what the graph is showing you. Everything must be in sync. Everything must be consistent. All right. This question says the graph below shows 2 lines, L1 and L2. So this is the L1, and this clearly then is the L2. Just as they label it down here. All right, line 1 and line 2. So this one has a negative gradient, as you can see. You can also see the y-axis intercept on this one is 2. But this one has a positive gradient. That's a line 2, because sloping upwards from left to right. And the y-axis intercept on this one is -3. So that information you can see. All right. They said that the L1 and L2 says L1 intersects the x-axis and y-axis at 4, 0, and 0, 2, which we can see here and there. All right. And L2 intersects x-axis and y-axis at 1.50 and 0, -3. Again, you can see them here. This is 1.50, and this is 0, -3. So like they're giving us those points to help us calculate the gradient. All right, but we don't need to use them. We don't need to use them. All right, but that is us confirming that information. What they want us to do, they want us to determine the equation of line 1. To get the equation of line 1, we need two things. We need a gradient and a point of line 1. So the point, if you can see the y-axis intercept, you're good enough, line 1. And the y-axis intercept on line 1 is 2. So you can write that down. The C is 2. So I have the C already from the diagram. The C is 2. And we can count out the gradient of line 1. Let's call it C1, meaning C on line 1 is 2. And let's count out the gradient. So we just need to find 2 points on line 1 and count out the gradient. Any 2 points. Right? You can use this point and this point, you know. So it's rise -2, run 4. So it's -2/4 right away, you know, which is -1/2. All right. But you could use any 2 points as you like. You could choose 2 points up here, for example, here and here. And go from left to right in those 2 points. You have to come down 1 first. So that's a -1 rise and then run 2. You're going to make sure that is 1 this, you know, by looking at the scale, because this is from 4 down to 3. So that's correct, a -1. And this is from 4, -4 over to -2. That's a run of 2 units. And you're going to confirm that. So the gradient of line 1 is -1, rise -1/2. So -1/2. Right? So the gradient is rise over run between those 2 points. We can use any 2 points, -1/2. And so the equation is y equals mx plus c. Once you have the m and the c, you're going to use them. So it becomes y equals -1/2x, and the c is 2. That's it. You can fast, nice and easy. So when they give you the graph, the questions are much easier to do. All right, 3 marks for doing that, you know, guys. 3 marks for doing that. So that's easy 3 marks. Next one says, what is the gradient of line 2? Given that line 1 and line 2 are perpendicular. So then perpendicular, they have negative reciprocal gradients. So see, you know, the gradient of line 2 is -1 over the gradient of line 1. What's the gradient of line 1 again? It's -1/2. We just worked it out a while ago. -1/2. See there? So you know, you have to flip the one that you have and change the sign. So this calculation, I'll put this under here. The quick way to do this is to flip this gradient and change the sign. It's going to become 2. We can confirm if it is really 2 from the diagram by using 2 points and rise and run. Let's see on line 2. So it's a line 2 here. It's a line 2. You can choose 2 points on it, like for example, here and here, and make sure that it is correct. 2 is correct. So going from left to right, guys, always think of going from left to right. So going from left to right, starting here to go over to there, you have to rise 2 up here. So first, see, it's 2 you rise, and then run 1. So it's rise over run. And that line 2 is 2, rise 2 over 1. So see, it is 2. So you confirm it on the graph. So you're consistent. So the answer is 2. So we could calculate it using negative reciprocal, because they tell us that the perpendicular, or also confirmed it by rising and running. But I think they want us to use this relationship in this question, not to check it off on the graph. That's why they told us that it is perpendicular. So we'll calculate it this way. It is 2. But good with that?
Yes, sir.
All right. And that question is done. Nice and easy. You can fast. All right. So you see, I have no business getting these questions wrong in exams, guys. They're too easy. Let's look at another one. 2019. There's another one on 2019, January 2019. Let's look and see. January 2019. I have about 3 more questions. We can call it a day. All right. And you know your task already. I don't have to tell you. You need to go. I'm going to tell you still, even though I don't need to tell you. You're going to go and you're going to redo all these examples that we did. You're going to watch the video, right? You're going to watch over the video and you're going to redo the questions that I did. All right. So you're going to watch the video, bring up the questions, and you're going to, do them. All right. If you message me individually, you see, I can send the papers in the group as well. You can send the papers in the group if you want, but you can also just try and do them from the video. Watch back the video, pause the video, work the question. All right. All right, let's go. This question says, the graph below shows a straight line intersecting the x and the y-axis, x and y-axis. I might just try and see if I can send the papers in the group. All right, see if I can send the papers in the group. So you can maybe work them from the papers, print the relevant page and work them. These past papers have a lot of pages, right? So you don't necessarily want to print out all of them. But the ones with the graph, you have to draw on. You don't have to draw from them. None of these we are drawing on. You can zoom it up and count off what you need to count off. All right, so you can still do it from the video, guys. All right, the question says, the diagram below shows a straight line intersecting the x and y axis, right? So you can see that that's a straight line. So this is the y-axis intercept, that's the x-axis intercept. This one I call this one down here P. Let's count it off. This is 1, 2, this is 3, this is 4, this is 5. This is 1 down here, 2, this is 3, and this is 5. So this y-axis intercept clearly is 0, 4. So C is equal to 4 on this line. And we can actually count out the gradient. So there are no points in between here that we can use. So the only points left to use are this one and this one. And you can see that the rise is -4 and the run is 5. So the gradient is off the bat is -4 or 5. Right? The gradient is -4 or 5. So the gradient of this line is rise -4 over run 5. All right, let's see what I want us to do. Don't want to determine the gradient. We just wrote it down a while ago. Because we have the graph, we can count it off. We don't have to calculate it because it's on a graph. And you can count it off. You just need to know 2 points and check the rise and the run. So the gradient is rise over run between 2 points on the graph to show us the graph. From here to here, we say they're going to rise -4. -4, can you come down 4 and run 5. Run 5. Now the gradient has to be negative because see, going from left to right, it's sloping down. So if you made a calculation and put 4 or 5, you know that you make a mistake because the gradient has to be negative. That's why we did the thing in the class about looking at the line and know whether the gradient is positive or negative. And how you do it, you think of going from left to right. Going from left to right, you're going down, that's a negative gradient. Going from left to right, you're going up, then that's a positive gradient. Remember, gradient is 0 if you're going straight across. Going straight across, gradient is 0 because there is no rise, only run. And the gradient is, if you have a vertical line, the gradient is undefined because there is no run. You have a rise divided by 0, there's no run. So the gradient is undefined, infinitely large, if the line is vertical. Remember those things from class. Let's continue. You don't know what question I'm going to ask you, but this is the gradient of that line, -4 or 5. Next I want the equation. So we have the gradient, which is -4 or 5. I could see the C value on the graph. The C value was 4 right here. So no calculation needed again because it's there on the graph. 4. So the equation becomes y equals mx plus c. So it's a lot of time you don't need the BFF for these questions when they give you the graph. You see the m and you see the c from the graph. So you just use it. -4 over 5x plus 4. Done. That is it. 1 mark for that. That's how easy it is. Because you can see the gradient and see the y-axis intercept. Okay, you can count out the gradient. Now the one equal perpendicular line passing through P. What is the point P? P is a point, let's mark it down. P is the point 5, 0. 5, 0. 5, 0. They want a perpendicular line. Let's call it line 2. So the perpendicular gradient is -1 over the gradient of line 1. So we're calling this gradient the gradient of line 1. So to get this perpendicular gradient, we flip this gradient and change the sign. So it becomes 5 over 4. You flip it and change the sign to a positive 5 over 4. So we now want the line with this gradient passing through this point. So that's how our BFF is going to come back and use now. So that equation is going to be y minus the y value at the point P, gradient of line 2, which is a perpendicular line, into x minus x value at the point P. So it's y minus the y value at the point P is 0. So put in 0 here. equals the perpendicular gradient is 5/4. 5/4 into x minus x value at the point right here is a 5. Is a 5. Since this over here is just y alone, just y. I'm going to write y equals, just multiply this over this bracket. I'm not going to bother to multiply the 4 by this side this time. So it's 5/4 times x, that's 5/4x equals 5/4x. And then this time, this -5, you're multiplying the 5s and put it over the 4. So you're going to get minus 25/4. And that is my line. Better go with that.
Yes, sir.
Anything else? No, the question done. Finish. All right. So I wanted to work over these questions, guys. All of them. More maths equals better maths. You have to practice. Let's look at 2018. I'm going to finish just now. Let's look at 2018 next. 2018, January 2018. Where are you? January 2018, right here. January 2018 paper. All right, so this is it now. So this one don't give us any graph, right? So it's a bag of calculations. But this is a different question. This is the next topic we're gonna do. That's why I tell you have to know coordinate geometry. See, this question have some lines in it as well. See that? All right. This is the next topic we're gonna do. Linear programming, inequalities, linear inequalities, and linear programming. So we have to do coordinate geometry in order to do this one. So we have to ensure that we know coordinate geometry first. All right, let's look at the coordinate geometry part of this question. It says, the equation of a line is this. And you can see it is not in the form where it equals X plus C. And it's helping you because they are telling you to put it in that form. If they did not tell me this, I would still do it. Because I want to be able to see the gradient and the y-axis intercept. All right, but let's go. I want to make y alone the subject. This is right now negative. All right, so I'm going to choose a part and bring it over this side first. So I'm going to get 3x equals 4y plus 5. All right, I'm going to take the 5 and bring it over here and get 4y equals 3x minus 5. Then to get rid of this 4, I need to divide through by 4 or multiply through by a quarter. Let me put it that way. I'm going to multiply through by a quarter. To divide through by 4 is the same as to multiply through by a quarter. So what would happen is that this becomes 3/4x. 3/4x minus, this becomes 5/4 minus 5/4 equals just y. So if I switch it around, it's the same as saying y equals 3/4x minus 5/4. So this is my m and this is my c. Simple as that. All right. Now they want us to hence, meaning use the result from up here. Hence, determine the gradient of L. So that gradient is equal to 3/4. Better go to that.
Yes, sir.
All right. Next part now says a point P has these coordinates and they are on L. Determine the value of R. You know what that means? It means that this point satisfies the equation. We can substitute the point into the equation for the x and the y value. And since it's the x value that I want, the R is the x value, you know, I can actually substitute it in the original one up here. Either one. And that's what I'm going to do. I'm going to put it in the first one. So this line, this point, because it is on the line, it works in the equation. So I'm going to substitute it in the equation. 3x minus 4y equals 5. I can substitute these points in this equation. No, that on this point, let me use a different color. On this point, right, the x's are and the y is 2. So I can plug these into the equation and work out what the R value is. All right, so I'm gonna put them in there now. Let's use a different, let's use the same blue. So I'm gonna get 3 times the x value where the x value is r. So I'm gonna get 3r minus 4 times the y value, but the y value is 2. Minus 4 times 2 equals 5. And so I'm solving now for the r, right? Now this 4 times 2 is 8. The 8 going to come over here, I'm going to come a positive 8. So I'm going to get 3r equals 5 plus 8. Now 5 plus 8 is 13. So I'm going to get 3r equals 13. I'm going to divide by this 3 now. I'm going to say that implies I end up getting that. Let me shift these over. Let me shift these over. No, these. I'm going to get from here that the r is equal to 13 over 3. 13 over 3. That is the r. Want to go to that?
Yes, sir.
I substitute the coordinates into the equation of a line because the point is on the line. So the point satisfies the equation of a line. It means that you can substitute the x and the y coordinate on the point into the equation. All right, that was a 3x minus 4y. Good, I was checking. So I put the r for the x and put the 2 for the y. And it work out itself. The 3r minus 4 times 2 equals the 5. So the 5, making sure yes, so the 5. Because I don't kind of like that answer. I'm just double checking. And so I get 3 times r minus 4 times 2 equals 5. And 4 times 2 is minus 8. Negative 4 times 2 minus 8. Minus 8 transpose to give me a positive 8. 8 and 5 is 13. And then divide by 3. So r is 13 over 3. That's it. Don't say anything wrong. Next part says now find the equation of a line passing through this point, which is perpendicular to L. Remember, to find the equation of any line, you need the gradient and a point. They gave us the point and they gave us a way to find the gradient by telling us that it's perpendicular to L. Let's call that line 2. So because it's perpendicular to L, the gradient of line 2 is minus 1 over the gradient of L. The gradient of L is what? What is it? This. So we're going to flip that and change the sign. This is the gradient of L. So flipping the gradient of changing the sign. See here, the gradient of L is 3 over 4. 3 over 4 from this. 3 over 4. So flipping that and change the sign to get the perpendicular gradient that we want. When you flip this and change the sign, it becomes minus 4 over 3. So we're using this gradient and this point now to get the equation. All right. So it becomes y minus the y value at the point equals the gradient of the second line into x minus the x value at the point. That is the equation that we're getting now. The equation. So it's y minus the y value at the point is 0. 0 equals the gradient of that perpendicular line that we want is negative 4 over 3 into x minus the x value at the point right here is 6. 6. Since it's just a 0 over here, again, I'm not going to multiply this across the bracket. I'm not going to bother to transpose the 3 over here. I'm just going to get now y equals, as this side becomes y. This is negative 4 over 3 times x is negative 4 over 3x. This minus is going to make this a plus. And then the 3 is going to cancel into this 2 times, and then the 4 times 2 is 8. I'm getting a positive 8 right here. That is my answer. This is my answer right here. But can I say that?
Yes, sir.
All right. We're moving on, and the question is done. Very good, very good. Sure.
Yes, sir.
All right. I'm taking it that you're telling the truth. 2 more questions. 2018, no, 2017, no, last question for the day. What time is it? Just about time. I think we started a couple minutes after 11, so it's just about the 2-hour mark. All right, so we're gonna end it just now. So one more question, and then we'll call it a day. Class tomorrow starting a new topic. It should come early. 2017. There's a perpendicular bisector question I left for last. For us to do today. Perpendicular bisector. 2017. January 2017. That perpendicular bisector on it. This is it. Let's do this one and call it a day, guys. This question gives us 2 points, P and Q. So P is this point, Q is that point. Another worded question, no diagram. It says they are the endpoints of a line segment PQ. All right, so you have a line PQ, those are the points at the end. We want to determine the gradient. So remember now, because we only have the 2 points, we're going to use gradient difference in Y by difference in X. That's what we want to use. So the gradient of PQ, we're going to use this point minus this point. Remember, it's a difference in the Y values. Difference in the Y values over the difference in the X values, because it is rise over run, point of PQ. So like so we're using this point minus this point. So we're doing the difference in the Y values first. So it's this Y value minus this Y value. All right. So it becomes 7 minus this Y value is -1 over. Then it's this X value minus this X value. So that becomes 2 minus 6. This minus minus a plus, so it becomes 8. This is 2 minus 6 is -4. 8 divided by -4 gives me -2. So that is the gradient of PQ, -2. But go to that.
Yes, sir.
Let's write it down here. The gradient of PQ is -2. All right, let's continue. Then we want the coordinates of the midpoint of PQ now. Midpoint. Let's write them down again. P was what again? P is 6 minus 1. P is 6 minus 1. And Q is 2, 7. 2, 7. What I want the midpoint. Let's call it M. Capital M. Remember, the midpoint is like an average point. So you're averaging the X values. You're averaging these two X values. For the X coordinate at the midpoint, you get X plus 2, 6 plus 2, sorry, divided by 2. You average them. Then you're averaging the Y values, the -1 and the 7. You average them. -1 and the 7. You average them mean that you add them and divide them by 2. Then that reduces to, this becomes 8. Sorry, press the wrong thing. Let's continue. Right. This becomes 8. 8 divided by 2 is 4. The 6 and the 2 here is 8. 8 divided by 2 is 4. Then this is -1 plus 7, same as 7 minus 1. 7 minus 1 is 6. 6 divided by 2 is 3. So the midpoint here is 4, 3. Then the next part says, find the equation of the perpendicular bisector of PQ. We did this in class. The perpendicular bisector. Let me explain it one last time. The line that we want is perpendicular to PQ. So therefore it has a perpendicular gradient, which is the negative reciprocal. Then also bisects PQ, meaning that it passes through the midpoint of PQ, which is this. So if we were to do a little quick sketch of it, let me just see if I can do a proper sketch. 6, -1, 2, 7. So 6, -1. So like P is down here and Q is up here. So this is the line PQ. The perpendicular bisector is this line I'm going to draw in red. Passes through the midpoint and is perpendicular to it. This is a perpendicular bisector. Let's call it line 2 for now. Let's call it perpendicular bisector. Let's call it line 2. See, it passes through the midpoint that we just calculated, M, which is 4, 3, and is also perpendicular to PQ. Therefore, the gradient of line 2 is the negative reciprocal of the gradient of PQ. To find the equation of this red line, we need to know two things about it. We need the gradient and we need a point that it passes through. The point is there already. It passes through the midpoint, 4, 3. What we need for it now is the gradient. We're going to get the gradient of line 2 using the fact that it is perpendicular to PQ and perpendicular lines have negative reciprocal gradient. So we can say this. The point that we're going to use for that red line is the point M. Let's write it down. It is 4, 3. Then the gradient of that red line, we're calling it M2, is minus 1 over the gradient of PQ because they have negative reciprocal gradient. They are perpendicular. And this calculation is done quickly by flipping the PQ gradient and changing the sign. Gradient of PQ is negative 2, you know. If you like, you can put the negative 2 under here and you will get a half. Or you can flip the negative 2, it's going to become a half anyway. So if you put it as minus 1 and put the minus 2 under here, the negative will cancel and give us a half. So that's how we get the half. Or put another way to do this calculation, we can flip the negative 2 gradient that we have and change the sign. This negative 2 is same as negative 2 over 1. If we flip it, it's going to become 1 over negative 2, and then we change the sign afterwards to a half. And that's another way we can get the half. So anyway you want to look at it, the perpendicular gradient is a half. So using that gradient and this point now, so the equation of this red perpendicular bisector, the equation of that red perpendicular bisector, we're calling it line 2, is y minus ym, because we're using the point m that it passes through, equals the perpendicular gradient, which we call gradient 2, into x minus xm. So it's y minus the y value at the point is 3, equals the perpendicular gradient is a half, into x minus the x value at the point is 4. 4. Now, because when I multiply this half across here, I'm going to get a whole number when I multiply by the 4. I'm going to just multiply the whole half across this bracket. So I'm going to get y minus 3 equals half times x is half x, and y times 4 is 2, but a negative 2 I'm going to get. Then this negative 3 will come over and become a positive 3. So I'm going to get y equals half x minus 2, and then this positive 3, I'm going to write it over here. Then the positive 3 minus this 2 is 1. So it's going to reduce to y equals half x plus 1. And this is my answer right here. That's the equation of that red perpendicular bisector on the diagram. The question is done. But understand that?
Yes, sir.
Yes, sir.
Everybody good? Everybody good today? Anybody have any
Yes.
question? All right, happy to hear that. So what you gonna do for me now, guys, all of you? You're gonna redo all the questions. All right, you're gonna watch over the video. Just go up to the parts that you understand, you can go past it. I wanted to redo the questions. All right, let me try and see if I can send some of the papers in the group for you to work from. Use the video to help you. Use the video to look back at anything you don't remember what to do. You need to understand this topic. You see that it is all over on the papers. It is one of those questions that we call short marks questions. But there are not a lot of different things that they ask you to do with these questions. You need to learn how to do all these basic things that they ask you to do and get them right, get them correct. You need to work with the perpendicular lines, the parallel lines, the midpoint, gradient, all these things. You need to be able to understand that you can look at the graph and determine from the y-axis intercept. You need to understand that you can determine the gradient by just counting off rise over run between 2 points. That's clearly on the lines. All right. And so you need to redo all these questions that we did today. There's not going to be a lot of different things that they asked you on the exam to do. with this topic. There's not gonna be a lot of stuff outside of what we did today. All right. So if you can rework all these questions that we did, all right, including the classwork, if you didn't get it right, I didn't understand it fully, or you can redo it. We did 1, 2, 3, 4, 5, 6, 7, 8, 9. Only 9 questions. Okay, redo all these 9 questions today for me, please, before coming to class tomorrow and Monday. Those who come in on Monday, redo them before Monday. Those of you who come into class tomorrow, you will have today to redo them. Do them over for me, please. Get them right. We're moving on to a topic tomorrow that you're gonna have to be comfortable with these coordinate geometry thingies. All right. So I look forward to see you all in class tomorrow and Monday. All right, guys.
Yes, sir.
So I try to see
Yes,
if I can send. I try to see if I can send some of the papers in the group. All right. I'm gonna send the papers in the group. I'm gonna see if I can find them and send them in the group from my phone. All right, guys. Bye. See you. All right. Bye, everybody.